So finally, in summary, to summarize all the most exciting points of this lecture for the seminar, the US and the world terrestrially, this thorium offers immense supply of energy that can last several thousand years, with no CO2 emission and no pollution, no pollutants, none, unlike coal or any other. No high pressure explosion possibility, as I showed earlier, none. Twice the efficiency of conversion to electricity, SPWR, twice. Natural and fail-safe freeze valve mechanisms available. Less than 1% radioactive waste products compared to 95% for PWRs of today. No plutonium. No plutonium is produced at all in this reaction mechanism. No plutonium that can be used for nuclear explosives. It does not need to be near a water supply. Today's PWRs are all, if you realize, they are all near some kind of a water supply, whether it's a river or lake or ocean, not needed here. It can be in a desert. Sahara Desert can have this plant. Any other desert in Southwest, anywhere can have that. It can be refueled continuously with chemical processing in the loop without having to shut down the PWRs. So immense supply, no pollutants, no explosion possibility, higher, twice the conversion efficiency to electricity, fail-safe mechanism, less than 1% radioactive, which is amazing. What more do we want? What more do we want? It's an amazing promise, amazing solution. And to not take advantage of this now would be a real shame. So I respectfully urge this administration to take this idea very seriously, and provide funding for it, at least for research and development and engineering to begin with, at least. Let's solve all these problems, and let's solve that with the help of institutions and universities, and provide funding for them to do that, and then we'll go to the next step. Let's start small and go to the next step afterwards. So that's my humble request to the administration. Lastly, since I'm here at University of Maryland giving a talk, I would like to suggest a few things that can be very useful for the university to do, maybe as a contract or a grant or whatever. A computation for ME department, from mechanical engineering department, a computational analysis to assess the heat transfer in heat exchangers. Build a small, 30 centimeter dimension, 30 centimeter by 30 centimeter type, 3D printed simulation, but no reactor for now, to confirm the containment, the pipes and the heat exchangers, that they can work for a long time and they can be sustained and not corroded over many months, maybe a year. Containment pipes can be made using some of the new materials that has been developed by, at least I know, GE CSIC material being suggested for hypersonic flights, etc., for high-speed flights. For the aerospace engineering department, I would obviously suggest many possibilities here for research topics for cislunar and moon Mars travel. They are very promising, which can be analyzed by students through research topic, graduate students through research topics for master's PhD, for their thesis topics. Then topics based on repurposing of nuclear TMSR, which I showed, a rocket for energy on moon and Mars, This, must be explored and papers published, and this could be very exciting for the new space age that we are going through now for students. Then it's also possible to fly this vehicle on Mars. Mars has atmosphere or 100th as thick as Earth, but regardless, it has atmosphere, so we can heat that atmosphere and make it go through the nozzle, heat it with this TMSR, make it go through the nozzle, create thrust, and have a vehicle that can fly 10 milligram of thorium or uranium-233 would be able to fly this vehicle that we designed one orbit around Mars. 10 milligram. I mean, compare that to the amount of propellant, chemical propellant that we require to do that. It's immense. It would be immense. Here, 10 milligrams would do that. If you take a few kilograms from here, you would be able to, do a lot of things, which can be done for future colonies, Martian colonies, or even before that, for experimentation, for mapping, and then later on for transport. So all in all, just amazing possibilities here for mechanical engineering department, aerospace engineering department, and if we have a nuclear engineering department, which is my last request here to start back, revive the nuclear engineering department here at Maryland University School of Engineering, partly centered on thorium molten salt reactor. That's my humble request, and humble request to university, and humble request to the administration in the previous slide. Finally, I would like to end with this painting that I made of first woman on Mars must go gingerly. As you can see here, she's going so gingerly and just like a river flow here, and so gingerly as to not impact, not affect the topography of Mars or climate of Mars. Let's call it that. Certainly topography or geography of Mars. So with that, I thank you very much for listening. Thank you.